You've probably heard that with the increasing carbon dioxide concentrations in our atmosphere, that one of the effects of this is that the oceans are becoming more acidic. So the question comes to mind of how is carbon dioxide acidic? We saw in the last video that Svante Arrhenius, defined an acid as a substance with hydrogen in its formula that dissociates in water to produce hydrogen ions. And carbon dioxide does not have hydrogen in its formula. There is no source of hydrogen in order for it to produce hydrogen ions. So the question is, how is CO2 acidic? How is it that CO2 is acidic? And this is our first exception to the Arrhenius theory of acids and bases. How is something like CO2 acidic? You can actually test this out in a lab. I'm not going to say test this out at home because you need a pH color indicator. And if you were with me in class, we would try this out in class. But you can actually take put some water into a flask, put some color indicator in there, and blow bubbles into the water. And what you would notice is that the indicator would turn into a color that reflects its acidic pH. And so just blowing bubbles and when we into a sample of water is putting CO2 into the water, and that actually makes the water acidic. So how is it that CO2 has some acidic properties in water? Well, to explain this, we need to make some modifications to the Arrhenius theory. And in the last video, we defined a Arrhenius acid as an acid that has hydrogen in its formula and dissociates to form hydrogen ions. To understand how CO2 is acidic, we need to understand something that was discovered in the early 20th century. And this discovery was the hydronium ion. The hydronium ion. And the hydronium ion is the result of this particular reaction. So earlier we said an acid was something that produced hydrogen ions in solution. It had hydrogen in its formula. And then those hydrogen ions are what gave the acidic properties and allowed it to conduct electricity. Now, hydrogen ions in solution are going to be around lots and lots and lots of different water molecules. And you might recall that a water molecule has a V-shaped structure with a slightly negative oxygen and two slightly positive hydrogens. And you could probably imagine this slightly negative oxygen in the water molecule could easily make a hydrogen bond, or even like a full bond, covalent bond, with a neighboring hydrogen ion like that. This has a full positive charge and there's a slightly negative charge on the oxygen of the water molecule. And what we actually see happen is the formation of a hydronium ion, and this is what we call a hydronium ion. Right? So that's a hydronium ion, and actually, to give you an idea of its structure, it's got a central oxygen atom, and 3 hydrogens around it. And it's got one lone pair like that. So this would give it it has a tetrahedral electron pair arrangement and a trigonal pyramidal geometry. So it's one oxygen with 3 hydrogens around it. So in reality, like it's a little bit more accurate to think of hydrogen ions in water as hydronium ions, because hydrogen ions will react with water to form hydronium ions. And this is the key to understanding how we can find substances like CO2 that display acidic properties. So it's this presence of a hydronium ion. So we're gonna make some modifications to this theory that involve the hydronium ion. So how is CO2 acidic? So let's have a look at this question. If I put some CO2 in water, I'm drawing double arrows here to show that this reaction is reversible. It can go backwards and forwards. That's not something that we'll really look at until you get to grade 12. But I do that anyway just for accuracy. Carbon dioxide plus water produces a compound called carbonic acid. This is carbonic acid, and notice that it has hydrogen in it in its formula. Well, carbonic acid can then go through another reaction. Okay, carbonic acid can then go through another reaction with, sorry, I drew the arrows too soon. I'll put it down here. Carbonic acid can now also react with water, but it gives it a different reaction. This time, carbonic acid, instead of just giving its hydrogen ions and the hydrogen ions existing just by themselves in solution, those hydrogen ions react with water to form a hydronium ion. So it's like the carbonic acid loses that hydrogen ion goes and reacts with water to form hydronium ion, and then we form an anion of carbonic acid over here. So this is kind of a little bit more detail showing us how carbon dioxide can eventually lead to acidic properties. The acidic properties are really coming from the presence of hydronium ion. And that results from hydrogen ions reacting with water to make hydronium ion. So if we put some CO2 in water, it'll make something called carbonic acid. It'll react to form carbonic acid. Carbonic acid then in turn reacts with water to produce hydronium ions, and this is called the hydrogen carbonate ion. Okay, so that's one of the reasons why carbon dioxide is acidic. So what modification do we need to make to the theory? Well, what we really need to say then is an acid is a substance that reacts with water to produce hydronium ions. Which look like that. So it's no longer that an acid is something that just has hydrogen in it and it dissociates to make hydrogen ions. An acid is a substance that reacts with water. We can't assume that water just sits there and doesn't do anything. Water is actually an active participant in the production of acidic properties. So an acid is a substance that reacts with water to produce hydronium ions, just like this. So I'll do a little bit more of a simpler example. Let's say we take hydrogen chloride, but this time we're going to react it with water. And this is the forward reaction here is quite strong, but I'm going to just, for consistency, show it as having double arrows. So hydrogen chloride plus water, what happens here? Well, normally this would produce hydrogen ions and chloride ions, but we can't discount the fact that these hydrogen ions are going to react with the water. So these are going to react with each other. So what do we actually get? Well, we're going to get hydronium ions and the leftover here, and the leftover chloride ions. So once again, this can be used to explain something that has hydrogen in its formula, or it can explain the acidic properties of something where hydrogen is not in the formula. Okay, so an acid is not necessarily something that has hydrogen in its formula, but it's a substance that is going to react with water to produce hydrogen ions in water, and those hydrogen ions will react with the water to make hydronium ions. That is the definition we're going to use in this course. When you take Chem 30 next year, we're going to broaden the definition a little bit more, and kind of work around this, but this is kind of the definition we keep through Chem 20. All right, I'm going to do another video like this, but I'm going to use it to explain bases, how something without hydroxide in its formula can still be basic. All right, see you in the next video.